Back. Problem 7. Find the volume of the solid that results when the region bounded by y equals square root 169 minus x squared and y equals 5 is revolved about the x-axis. So let's understand the picture. Y equals square root 169 minus x squared. You want to understand this curve. Square both sides. Y squared is 169 minus x squared. Move the x squared over. X squared plus y squared is 169. Now this is familiar. This is a circle centered at 0, 0, radius 13. That's the square root of 169. Now, so you have the circle. What happens when y equals 5? Why do I point out y equals 5? Because that's part of your region. Okay, you want to be bounded by y equals 5. When y equals 5 on this circle, substitute y equals 5. X squared plus 25 is 169. X squared is 169 minus 25. X squared is 144. So x is plus minus 12. In other words, so that's your circle. My original curve is y is positive square root. So we are simply looking at the top half. Y equals 5 is this particular line, horizontal line. When y is 5, x is 12 or minus 12. So those 2 points, intersection points, are negative 12, 5 and positive 12, 5. And the curve above is y equals square root 169 minus x squared. So the region between the top half of the circle and the horizontal line is this shaded line, shaded region. You want to take the shaded region and rotate it about the x-axis. So you want to take it, rotate it about the x-axis. So when you rotate it about the x-axis, mind you, so you're going to get a solid, that part, and a solid in the a little less, not all of this lower hemisphere, somewhere here, right, until there. So it's going to be a solid, almost like a sphere, but with a big hole in the middle. In other words, you're going to have an outer radius and an inner radius for every cross-sectional section, basically. So you have vertical cross sections. So x goes from negative 12 to 12. Outer radius is from here to here, that is the y coordinate, which is square root 169 minus x squared. So pi radius squared minus inner radius is this distance. Well, that's y equals 5. So that's inner radius. So once we have set up the question, it's straightforward. Pi is common. It comes out negative 12 to 12. Negative 12 to 12. By symmetry, I only take the right half, 0 to 12, and double that area. You see, that's twice of this. So when I open this out, square cancels the square root, minus 5 squared is a 25. Remember, the pi is a common factor. It's outside. By symmetry, I am taking the integral negative 12 to 12 to be twice the integral 0 to 12. Once I do this, I get 169 minus 25, 144 minus x squared. You proceed to find its integral, x cubed by 3, limits 0 to 12. So this is the advantage of using symmetry. 0 makes sure you have less calculation to do. 0 fetches you nothing. All you have to do is substitute 12. When I do that, I haven't even simplified it. So let me simply write down the expression I have here. 2 pi bracket 144 times 12 minus 12 power 3 over 3 bracket. It all works out. Next problem. You want to look at the volume of the solid obtained by rotating the region bounded by y squared is x equals to y about the y-axis. All right. Y squared is x equals to y. You need to understand how the curves look like. Y squared is x, that is x is y squared, and x equals to y. So you need to find these two intersection points. How do we find the two intersection points? X is to y, x is y squared, so set y squared and 2y equal, which brings us y squared minus 2y equals 0. Get a factor of y, y minus 2 is 0. So y is 0 or y is 2. You have two options. Y is 0 and then y is 2. Notice the y coordinate, 0 and 2. Once you have the y coordinate, x coordinate, you would use either of these expressions and you get the same answers. Y equals 2 gives me x equals 4. Y equals 0 gives me x equals 0. So these are your 2 points. Now you want to take this region between x equals y squared and x equals 2y, right? This is a line, that's the parabola. You want to take this region and rotate it about the y-axis. Is it about the y-axis? Yes, it is about the y-axis. So you want to take this, rotate it about the y-axis. So if you notice, I'm going to have horizontal cross-sections, outer radius given by 2y, inner radius given by y squared. All right. So outer radius given by 2y, inner radius given by 2y by y squared. And because these are horizontal cross sections, my y value goes from 0 until the maximum height of 2. So integral 0 to 2 pi outer radius squared minus pi inner radius squared integration with respect to y. Remember, pi is a common factor. This gets me 4y squared. This gets me y to the power 4. Integral 0 to 2. Y squared integral is y cubed by 3. Y fourth integral is y 5 by 5. All I need to do is apply the limits. When y is 2, I get eventually this to be the answer. All right. So that is pi bracket pi times bracket 32 over 3 minus 32 over 5 bracket. All right. Next problem. Let's continue in our next video.